A very good day to all of you. Thanks for taking time for joining in this into this webinar. I am a strong believer in continuous learning, and I truly believe such webinars are an opportunity for us to learn from each other's experiences, not just the panelists here, but I strongly encourage all the participants also to use the various options to interact, to provide feedback over the next 60 minutes. The theme for today's webinar is called Inside the SDV Revolution. And the basis of this theme and the webinar is basically a joint publication that Thoughtworks and AWS released a couple of months ago called the SDV Pulse. And even before getting into the content of this report, for me, the genesis of this report itself is pretty inspiring because it all started with a very simple LinkedIn survey that Daniel had posted. If I'm right, I think it's on November 2023, where he had asked if people would be interested in a cloud compute radar. And then I just left a comment saying that, yeah, let's do it together. And with that comment, I think the spirit of collaboration just started. And with over various conversations, we shaped this idea, taking heavy inspiration from the technology radar that gets released every 6 months by Thoughtworks. I think that was our inspiration to try and see if we can create a tech radar right report for the world of software-defined vehicles. Because we truly understand there's a lot that is happening in the software-defined vehicles space. And it's very important to be on top of the technology topics that are driving this transition into the SDV era. So that was the inspiration. And from there, we did a lot of workshops together with 10 experts, 5 from AWS and 5 from Thoughtworks. And through our experiences working in the world of mobility, try to bring up topics that we truly believe could make a difference in the world of SDV. So on that note, I'll also introduce my panelists. So my name is Sriram. I'm from Bangalore. It's a rainy evening here today, so I'm hoping that the internet connection is going to stay alive for the next 60 minutes. I'm with Thoughtworks in the software-defined vehicle space, and my current mission is to see how to grow the SDV space within Thoughtworks, and more importantly, add value for our partners in this automotive space. I would also like to invite and thank Daniel and Michael for joining in today. But I would also like you to probably pass on a statement as to what inspired you to do the SDV Pulse or what you like about the SDV Pulse together with your introduction. So Daniel, you first.
So what was the inspiration for me to start this whole thing? That was actually I thought it would be interesting what AWS sees in terms of automotive like technologies and trends and so on. And that is what I really liked, or what I really like about this publication. It is a snapshot of what the industry is going to head to. I'm Daniel Schleicher. I'm based in Germany, next to Hanover. I call myself a solution architect working for AWS. And I'm working, so my main driver is to help automotive customers make best use of cloud. Thanks.
Welcome, Daniel. Over to you, Michael.
Hello, everyone. My name is Michael. I've been with Thoughtworks for 13 years. My background is clearly in the cloud and in the web world, but the last 7-8 years I spent only on in-vehicle development. So my mission is to bring modern software development to vehicles. And yeah, I mean, I'm a developer, and what I enjoyed about the SDV Pulse was with friends, just come together and collect what we see, try to phrase it, try to make it digestible for others, but at the same time not having the expectation of doing like a full market research of things. Because either when I discuss people, it's like something very, very specific, the one thing, or like the broader scope. And I think, collecting the experience and the perspective of 10 people who have, views from different projects and clients, that should be interesting for a lot of people. Yeah, I really enjoyed that. It was more work than I expected, to be honest. I was never part public technology rate, I was like, oh shit, that's a lot.
Yeah. Talking about a lot of work, thanks, Michael. Of course, I would like to take this opportunity to acknowledge the team behind this report, right? So, Alexander, Christian, Daniel, of course, Francisco, and Sushant from AWS, Eric, Marcos, Michael, and Vivek from Thoughtworks, who all came together, spent quite a lot of effort and time in getting this report ready. But at the same time, I also would like to acknowledge the effort of our marketing teams who spend a lot of time to ensure that the output of the knowledge that we put in this is, very user friendly. So, taking time to thank all of them, I would also like to show how the report looked. So, of course, as I mentioned, it is heavily inspired by the technology radar from ThoughtWorks. And the SDV Pulse, as it stands, the best way to read it is just two dimensions. So on one dimension, you would see that the topics, which are 40 of them, are categorized into 5 macro themes. So concepts and solutions, ecosystem and organization, techniques and practices, technology and products, and trends. Of course, one might have an opinion that this is not a practice, this is a solution. Of course, I think this is something that we over workshops, over discussions, decided to categorize it into one of those boxes. So, and of course, what is always important is in terms of the maturity. So the other dimension of the classification that we have used in the SDV Pulse is clearly whether it's advanced phase or whether it's adoption mass. So what we would intend to in this webinar is pick up some topics that you see on the right hand side of the screen. Of course, I don't think so we are going to have time for all 40 of them, but I would strongly pick some topics that Daniel and Michael would talk through each of the themes. And the idea is to pause after every theme so that if you have some questions, if you have some feedback, if you would like to engage in discussion, we would use that time to take up those topics, then waiting at the end to finish most of the topics. So that's the plan. So I think it's time to accelerate and shift gears into the first session, which is concepts and solutions. So here you see that we have about 11 topics. Very clearly, there are topics around security, data, cloud, workbenches, and so on and so forth. Let's just get this started. So I'm just going to pause the screen for you to look at it because I'm going to take away the screen. It might be off and on, but I think that's the best way to listen to Daniel and Michael and not necessarily see the screen. So we're going to pick 4 topics. Daniel would talk about the vECU and centralized architecture as an enabler for SDV. Michael is going to talk about data mesh and developer portals for vehicle APIs. So that's what we have picked on concepts and solution. But after they are done speaking, I'm going to come back to the screen and see if you have any thoughts, questions, or discussion points on the other topics. But for now, let's get started. Over to you, Daniel.
Thank you. Thanks, Freedom. Yeah, well, so my first topic, vECU and vECU levels, actually. So for me, vECUs are really one of the main parts driving an SDV and software-defined vehicle, right? So, and if you see what we at AWS aim for, we aim for giving you, the developers, our customers, the opportunity to concentrate on your core business. A vECU is something that we would like you to help you recreate, create on the cloud, and use this tool to concentrate on creating automotive apps. But first of all, what is a vECU, right? So an ECU, first of all, is an electronic control unit that is used that is deployed in a car. It's a metal box with a microcontroller in it. And in the former times before cloud, let's phrase it that way, there needs to be, so if I would place myself into a developer and developing software for a car, I would need to have an ECU next to my laptop on the desk. But with vECUs, this opens up a much broader or VCU is giving you much more flexibility. You could like send around this software hardware thing around the world, make use of different teams residing around the world. And yeah, so and that goes together. If that's okay, I would like to go over to centralized architecture. So that is a part of so VCU is a part creating a centralized architecture, because right now VCUs are like the first versions of a VCU are like the goal for them is to represent what we call an HPC, and high performance computer in the cloud, which is the main part of a centralized architecture in a car, right? And centralized architectures are the second thing that I'm really like looking for, that it will be developing more and more now, on that we see in at AWS for a number of OEMs. So this is also mass adoption, right? So we have here many OEMs getting toward that direction, because you are able to be creating software much more flexible too, because you don't need to manage all these software high performance software stacks running in a car on hundreds of ECUs anymore, but it's centralized, coming together. So yeah, that is here. That is something I can't stop right now, but there's lots more I can talk about. So handing over to the next topic.
Sure. Over to you, Michael. We'll come back to the main stage in a while.
You think what I quickly want to describe is we call it developer portals for vehicle APIs. I don't think there's that much to explain. It's a portal where you expose APIs that either give access to vehicle information, status information, but also if you look at APIs, some of them you can also send commands to basically change the status of the vehicle. Think about opening and closing doors, but also getting the charging stages and so on and so on. And I mean, we put it on there, not that almost all of the OEMs are all building their own developer portals and APIs, but also every time people are discussing SDV, software-defined vehicle, I think the word ecosystem comes in very quickly. But I mean, similar to what we observed in the big IoT wave, ecosystem just don't magically appear out of nowhere. And for us, we put it onto the SDV Pulse because we think that easy to use, easy to access vehicle APIs are one key element of creating this ecosystem where the car can become a channel for other digital services, but also the other way around. Car can become part of a larger system like a fleet management. And I mentioned before, we didn't do like a full market research, but when we compared the vehicle portals or the API portals that exist and that we looked at, the developer experience varies, I would say. Some are very easy to get access, some are very well documented, the sandbox come right away. Some of them, even with some effort, you can't really manage from outside to do anything with this. And to me, like for an OEM, making vehicle APIs as a default for car functionality and putting effort into that is not only for the outside, for the ecosystem valuable, but also for themselves. But also because it varies, we put it into early adoption. Still a way to go, but clear sign that eventually it will be there.
Fantastic. And the other topic before we come back to concepts and solutions is the data mesh, Michael. So
right, and don't worry, I'm not gonna recite the whole article from JMark, but in my very, very simple words, the concept of data mesh is to me a principle where I build data products as close to the data source as possible. And especially when it comes to car, you obviously have then many different data sources, and there seems to be a trend that that you try to build the data platform that makes all, right? But the problem is when you first of all, you get slow. If you add functionality, you want to tweak something, right? And somebody else takes care of the data platform. But also, and I mean, that's the reason why data mesh was so successful. You bring the interpretation close to the people who have domain knowledge, right? So you still want to have a layer that takes care of access, that allows people to give self-service infrastructure for data product, that takes care of the security, but you want the domain experts that really handle the data to also build the data product. And this is why I think the concept of data mesh applies to many domains, but especially also to connected cars.
Fantastic. Thanks, Daniel. Thanks, Michael. So I'm going to bring this slide back on screen. So maybe one question from my side, Daniel. So VECU or virtual engineering, when we talk about it, what has been your experience working with clients and partners? How are they seeing it? Is this something that they find it complex to adapt to? Because I've spent decades working with real ECUs, wiring harness, and now to not to think of that and start working on a virtual, setup. How complicated or how easy it has been?
Of course, the answer is it depends. I worked with a client, or I work right now still with a client, with a client team actually, which is really looking into the future, driving this thing at the bleeding edge. However, at that same client, there is teams creating ECUs, real ECUs, hardware ECUs, and it's quite hard to explain that new concept, especially if you think about the possibilities that come with virtualizing hardware. Actually, so you can decouple your software. The whole software development lifecycle from the hardware lifecycle. That is a real, so it's on the one side it's a real game changer. On the other side, it's really hard to explain what the advantages could be in the future.
Okay, thank you. So one question to you, Michael. You talked about developer experience a couple of times during developer portals. What would be your suggestion or piece of advice to the various SDV developers out there to embrace this form of development, right, where they can really, start working with these APIs, which is not the usual way of in an automotive software space?
I guess when it comes, what I often observe is that the people who build the in-vehicle software and the people who build backend services for connected features are well, minimum two different teams or two different departments, right? But if I put the responsibility, of the people who develop in-vehicle functionality or in-vehicle create in-vehicle data to minimum, right, connect to this API and the data platform, right, then you don't have this gap. Because most of the time when people draw an SDV connected service architecture, this physical gap between car and backend, right, well, it's a physical one, but from a logical perspective, it's a really bad one, right? So in a lot of projects where we build connected services, the team that had the functionality on the car also had at least the first layer of backend services. No payment, no user subscription, but at least expose this functionality. Because then, I mean, nobody can draw all the functionality up front on a board, right? So you have to iterate. And if you close this gap, right, then you get really momentum. This is why I think, yeah, thinking like this is a good one.
Is it possible to fully abstract away the hardware? There's a question from Pati. So maybe Daniel or Michael, would you like to take that?
Maybe I start, Daniel, you can chime in.
Please.
And also maybe looking at the comment from Joachim. Yes, I mean, obviously, other domains show that you can abstract hardware in a good way when you write then the lines of code for your function or your application, right? But at the end of the day, the software needs to run on something physical with limited constraints and limited constraints and limited resources. So while I think from a lines of code perspective, it's really possible to abstract the hardware in a nice way, I think we will never get rid of physical test environments and also to some level of manual testing. And I guess this then also goes into the comment that Joachim made, like you got 10 issues, 5 of them are because of the virtualization, and I guess it's a fair point, right? I mean, Chemo is not perfect. All the tools are not perfect right now. And I guess there will be an evolution. The tools will become better, but also the people will be better how to use certain tools and environments, like what the expectations are. I mean, if I think about the web world, if I do a Selenium test, clicking on a functional level, I don't expect to find it, like load issues I have on the backend server. And I guess we need to learn and understand that for the different environments as well. But I would not disagree with Joachim right now.
That's right. And I would like to add something that really inspires me every day to work for AWS. That is, so at AWS we are thinking about a concept that is called environment parity, where we want to provide, and we are able right now. So I have my client that I talked earlier with is doing that already. We are running the same binary that runs on the ECU, on the hardware, on the real target hardware. We are running that same binary, so the compiled binary, on the cloud. We are able to do that because we have the same instruction sets, so the same CPUs in the cloud as well as on the binary for some hardware components, I should say. And there's a number of technologies out there, also not only like virtualizing other like peripherals around that system on a chip, helping us to run that binary and not maybe have that challenge with finding like 5 issues from the virtualization, right?
Are there
Yeah.
any numbers? Honestly, I don't. I don't have them. But it seems to me, I think everyone for themselves, like can at least take a guesstimate in your development from commit to I find it in a bench or in a car. How long does it take, and how long would it take? Assuming you find a good number of things in virtualization, how much quicker is that? And to me, it's not like I don't think I need to. We don't need to prove that it's good to find things early. I guess what people should do is at least on a program level also say, what do we expect? How many bugs do we want to find in virtualization? How many bugs do we want to find in this environment and in that environment? Because everybody's talking about shift left, but nobody describes the target picture where we want to be or measures it, right? Like, oh, we found 80% of the bugs before we go to a physical test bench. Rarely OEMs have these numbers. So I'm sorry, I don't have the number.
Sure. So I think we are also slightly starting to talk about certain practices or ways of working that can be incorporated in the world of SDV. And that's exactly what we would pick up next. So again, there are about 12 of them here, right? Sadly, we didn't find anything in the mass adoption phase. So there are all topics scattered between concept and early. So we're going to take 2 topics in concept phase and 2 topics in early adoption for a brief. So I would like to start with Daniel again, who would talk about software first, ECU development, and localized peripherals.
Yeah, so software first ECU development is the natural thing if you think, so it's a natural next step if you think about a development team creating automotive software on a virtualized ECU, right? So you as a developer now are able to create software for a hardware that is not there yet, and that is software first ECU development. So you could like constrain what your computer resources in the cloud and also memory resources to fit a certain hardware that might be there on the market, but you don't need to. So you can with that setup, you're able to play maybe is not so good, is a not so good word, but experiment is maybe better. Play and experiment with new features, show off new features to management, for example, or fail fast. Create a new functionality on a virtualized ECU. And again, I would like to stress that you're creating the same binary, at least on AWS, you're able to do that. You're creating the same binary, and then you are able to deploy that binary on a certain set of hardware you are targeting. And not, for this, I'm stopping here right now because I think it's a better, and then see whether we have any questions, and then go to the second point, or maybe hand over to Michael and then.
Yeah. So two diverse topics, Michael. One on compliance, which is also very crucial in safety critical systems like automotive, and the other one is our favorite buzzword these days, which is AI, right? So let's talk about continuous compliance first, and then we move on to AI first, AI assisted software delivery, specifically in vehicle software. Over to you.
I like that there are more questions coming in. Maybe some of them we can chat. But I think what I want to point out first is number 19, continuous compliance. Quickly, the context of it in automotive, obviously software has to be compliant with certain regulations. I guess functional safety or cybersecurity are the ones that everyone. In Germany, we also invented such a thing as ASPICE, which is maybe not an official compliance, but at least within the ecosystem. And what we observed a lot is that what we call a compliance sandwich, that upfront of a program or a project, lots of thoughts are made, lots of designs are drawn. And I guess to a certain extent, you need that, right? You need to think about what functional safety mechanisms do I want to implement. And then nothing happens. And then at the end, you do all the other stuff. You do the documentation, the testing, the two-way traceability things, and so on and so on. And obviously, I'm exaggerating a bit here, but this sandwich is clearly a pattern that is happening in the industry. And the idea of continuous compliance is basically to make compliance more iterative and incremental. So if we ever want to push out over-the-air updates, every 4 weeks, every 3 weeks, every 2 weeks, you need to bake compliance in. You need, and therefore, the idea is to put all the information as close to the code as possible. I can certainly write a diagram in code with Plant UML or Mermaid, and then generate it as part of that. And then we generate all compliance artifacts as part of the pipeline. And the last thing is we make compliance part of the definition of done. And this sounds all very theoretical, but I guess with Ferrocene, the project from Ferro System, that is an ASIL D certification of the Rust compiler, they showed it's possible. I can do this in an incremental iterative way, only with open source tools. So to me, something like continuous compliance, or however you want to call it, is not optional. It's mandatory in the era of SDV. Oh, yeah. I guess the other points I wanted to speak about is 23. Obviously, we couldn't get around AI and Gen AI, and I like the quote I heard on some other event a couple of months ago, when people ask, can you solve it with AI? That's like asking, can you solve it with physics, right? The answer is probably yes, but it doesn't help, right? And I mean, initially, when you think about embedded in-vehicle software and Gen AI tools or AI in general for developing software, it sounds like a very stupid idea. Because one thing has to be correct and proven, deterministic, and the other thing is anything but this. However, I guess it's very fair to say Gen AI-based tools, GitHub Copilot is here to stay around. And also, if you think about the activities along the V model, we did quite a few experiments for different activities to do boilerplate and scaffolding for specifications, or at least, asking, what tests are missing, or for emissions compliance, at least for some of them that can't be done by a linter. I guess we will stick there, but I'm not worried that somebody will build an end-to-end AI for all the ECUs. So until I retire, this won't happen. And if I'm wrong, I'm okay to be wrong.
Oh, yeah, sure. I think as much as technology evolves faster, there are definitely certain topics which are that gain attention and attraction slower. So we're going to take some questions. I think there's at least one question on the Co-Visa, Sophie, and Eclipse SDV, but I think I'll park that once we get to that. I think we can answer that. But maybe we could take the next question. So maybe Daniel, could you please explain how VECU is looking like in a practice? Is it like a VM container repo? Maybe you could answer that.
I think it could be the first two options. Repo, I don't get that actually. But so for me, we started at AWS, we started in my project, we started with Android Automotive actually. We are, so it's a VM running on a bare metal EC2 instance, so an compute instance, AWS compute, where that is the easiest way to see virtualized ECU from my point of view. So there is Android software that is so where you can take the whole OS, Android OS, and run it on an ECU instance, AWS ECU instance. And there's also containers, right? So a container could be also hosting a virtualized ECU. Yes.
Sure. Thank you. Maybe one question from my side, because techniques and practices is about ways of working. So Michael, my question to you is, how does one, experiment these techniques and practices or newer ways of working? Do you have a, piece of advice, suggestion, or a template to follow to say that, okay, this is how you start experimenting these newer techniques, like using AI for in-vehicle software development? As you rightly said, it's something that we would need a deterministic output, but more often than not, we find it could be anything but that, as you said. So how does one embrace these new techniques into their projects?
That's a good. Sorry, I have to do the consulting. It depends, right? Because I've seen very different situations at OEMs and tier ones. So I mean, in the industry in general. Because I think sometimes you have people that are by nature very innovative, that can in a very lightweight way, just try something out, right? But I've also seen people who are very, let's say, used to the point of stuck in a certain way of working and a certain technology stack. And I guess everybody should decide for themselves, the people I'm working with, the departments I'm working with, what's the situation there? Because sometimes I think you need a push from the outside. I mean, I work for consultancy, so I must say that to some extent. But the question is always do things time boxed. I would say that's a good thing. Try something out and say, I'm going to focus on that half a day or a day. And then I make a call and discuss with others. Because I think people are two problems I see with adopting new ways: overly fixed on utilization, right? There's SOP. I don't have time, right? And guess what's after the SOP? Is another SOP, right? So you need to deliberately put a certain amount of slack in the system. And this is not the once a year hackathon Friday. And the second thing is don't try to solve all the problems right at once. It's okay if a certain method or tool has downsides, but learn how to use it. Yeah. Sorry, I didn't give a very specific answer, but I think, maybe I get some pointers.
Sure. I think we'll take one more question before we move on. I just had to come back after the presentation because for some reason I was not able to see the Q&A. But Daniel, maybe you could pick up this question from Yashashwini, who says, in traditional validation, peripherals like sensors, or at least a sensor simulator is used. How is this taken care in terms of ECUs?
Yeah, so this is also something that will come up in the next few minutes. However, we can talk about it right now. So peripherals, it's quite tricky actually. You need to find a solution for every peripheral. So there's, for example, Bluetooth connection, Wi-Fi connections, and so on. So I might give you one or two examples. So we managed it, for example, to use the I just call it now a metadata channel of WebRTC. WebRTC is a framework to send video streams around the internet and display it on a web browser. we use that metadata channel that comes with it to send Bluetooth signals to a virtualized ECU instance. But we're also we were also thinking about creating test drivers for other sensors that are in the car. That is also possible. You could just in quotes deploy another piece of software in the cloud and then connect it via IP Internet Protocol to the EC2 instance. And there is, at least for Android, for example, or for a number of other software stacks, there is interfaces that you would need to comply with, and then you're able to interact with. So in summary, every peripheral is different, and you need to find a creative solution for them. But I didn't see a showstopper yet.
Yeah, and
Sure.
maybe I think this is also where the tools will quickly evolve, because right now most automotive specific tools are really made for this. I got an evaluation board next to me, right? But if we think about the communication protocols, CAN, SUMIP, I can build that in the cloud. I can build a very simple, small tool that can have canned responses for SUMIP messages or CAN frames or video stream, right? And one of the things we once tried, the question was, why can't building a SUMIP service be as easy as a web framework in Python? It's perfectly possible. And at the end, we had one function, annotated it, and then I would not send this to production, but I definitely would use it as a mock tool for peripheral mocking.
Got it.
I will
Sure.
send the link.
Yeah, I was about to ask, but I think maybe both of you have also hinted as to how many of these topics are ready for production as compared to just rapid prototyping. But I think we have also made a point there for the people to understand which of this is ready for production. So moving on, I think the next one is technology and products. So maybe this time we would start with Michael. I'm inching to ask about Rust, but for now I'll ask you about ROS 2.
Oh, come on, that's like the first webinar I don't speak about Rust. No, Rust 2. For those who are not aware, Rust 2 is robot operating system. 2 is they made a major new version with tons of functionality. It's a set of libraries and tools for building robotic systems, and it comes with inter-process communication, multi-threaded execution, quality of service, and so on and so on. And we put it on because I mean I have used Rust 2 on a project. I've seen others using Rust 2 for in-vehicle software, and I've seen people that build something that looks a bit like Rust 2 themselves. And the question is then, so how come this is a thing, right? And I guess what is good, or what people do like, is if you have on an ECU level for in-vehicle software a more complex logic. Rust 2 has a node-based architecture and has a topic-based communication. Other people might know it from MQTT or something like this. And this seems to be just a very nice way of adding chunks of functionality without knowing upfront exactly everything or how everything will be. And also you might have certain functionality that's relevant for other downstream components. And Rust 2 seems to be just, a very easy to use thing in that way. And I think Apex even made a subset of it ASIL-D certified. They take money for this, but it's also possible then, right? This is why we put it on. I've seen it in the wild, but it's not like it's mass adoption, and certainly it's not suited for all the functionality in the car, but for certain things it's a really good choice.
Yeah, but I'm sure when we talk about ROS to our partners, it definitely raises an eyebrow and shows their interest in this topic. So talking of which, let's move to the next one in the mass adoption phase. So Daniel, over to you with point number 35.
Yes, hardware accelerators in the cloud. Yeah, this is something that is around for a number of years now. So NVIDIA is the name here, the buzzword here, right? So at AWS, we have a number of, excuse me, a number of hardware accelerators from NVIDIA, but we also have Qualcomm instances, so Qualcomm accelerators. And that comes handy for two use cases. One use case is that there are testing fleets are driving or are creating lots of data, sending that to the cloud to be used for training models, for example, AI models. And their hardware accelerator comes very handy, actually, to train a model, because it makes your life much more easy and you don't need to wait to train a model so long. But the other thing that I'm also targeting now is with my client is we are like creating a virtualized ECU where we are using a hardware accelerator in the virtualized ECU, in the best case with the same instruction set that we have on target hardware, right? And that is the other really nice use case now that we are facing.
So maybe we'll just move on to the next macro theme, which is trends. So here again, we'll pick one in early adoption and one in mass adoption. So maybe let's start with Michael, seamless development between partners, because for a while now, I think we've been talking about different players, and you also started saying, like the IoT world, there's this ecosystem play. In an ecosystem, we definitely see a lot of players who have now established strong partnerships as well. So what do we mean when we say seamless development between partners?
Oh, yeah, I like that. I mean, the context is often either sometimes people build an ECU and then the different layers inside this ECU are built by different people. The operating system, the base software, the application, or whatever, right? And then at some point, these people need to integrate. But also you can have the scenario that two ECUs are just because of the domain very close and need to have an iterative, development of those. And I mean, again, it varies on programs and OEMs, but still, I would say often these people integrate binaries on an integration bench, manually updated, right? Or when you get the base software, the tier one is throwing every 2 weeks the new version over the fence. Again, exaggerating a bit here, but I guess it's still a common practice in things. And I think there are multiple ways to integrate earlier and to collaborate in a closer way. So you can have a common build environment. I know people are afraid of our IP, right? But to be honest, I guess you just want to hide that you didn't write tests yet for your software. Or they say, oh, for legal reasons, we can't that. Well, then make the CEO change the procurement process, right? That's not that hard. Or I was once on a project and then they said, it was at an OEM. And they said, oh, right now we get for new software version every 4 weeks, the new version per email. At the beginning, we were sitting all together, right? And then the first 3-4 months, we just iterated very quickly, co-located. I'm like, what stops you from doing it again? And I know people always find reason, but I guess we have to look for ways how partners, right, can collaborate much better with each other. And also the word partner, let's be clear what we mean by this. It means like creating something together, not I can buy stuff cheap from you because you're my partner, right? Yeah, but I also, especially with all the improvements in virtualization, I know we said the word virtualization now 1,000 times in this call, but I guess that's one way. Have virtual integration environments, have contract testing. The test, if you don't run our tests or they are red, don't even bother sending us this because we need to have a conversation first, right? That's fail fast, fail early.
Fantastic. So I think we have listened to these terms: fail fast, fail early, rapid prototyping, and a lot of technology topics. But I think fundamentally what we also see is there needs to be a newer way of working, a newer mindset to embrace. And that's also an opportunity for most players in the automotive industry to experiment, right? Not just in terms of technology, solutions, building products, but the way they build it. So I think that's the topic which probably Daniel would now talk about. Topic number 40, which
Yes.
is the inherent need of the shift towards SDV.
Yes, that's right. So what I saw in the past is that the EE architecture, so the internal architecture of a car, is built by an organization where every ECU at least has one team assigned, and at least in the past there has been a number of ECUs, hundreds of ECUs, so maybe 100 or a bit more ECUs in a car. So there's lots of departments and teams need to work together, but every team and department is quite like in their silo, because they have their own suppliers, they have their own way of creating software on that stack. And for SDV, this needs to become different. So departments need to, maybe in the worst case scenario, give away power in quotes. So because their software or their functionality now will be run on a centralized centralized computer in the car. And that is the second point. So the first point really is we need to think about departments and functionalities and so on, but we also need to think about agility and what Michael really talked about. So people need to come together, sit on the same floor, and in this way they are able to take decisions. Sometimes, like I think it's 100 times faster or something, depending on your on the traditional process. So if you think about sync rounds every month or so, instead of like two people working together on one laptop, taking architectural decisions, right? So that are the two main points that I think of when I think about organizational shift towards SDV.
I know we're short in time, but very quickly to add, I think maybe to spin it a bit differently, or like organizational legacy is the biggest handbrake for people to transition into what people call the SDV era. If you think about the digital native car makers that sometimes make cars that fall apart, but on the other hand are really good at integrating things into end-to-end, having a short time to market. So the Rivian, the BYDs, the Neos, right? The Lucid maybe. They are not that much smarter or that much better or that much more software. They just don't have the organizational legacy and set up their ways of working in something that's focused on time to market rather than on get it right the first time around.
Absolutely. And I also would like to take this opportunity to say that none of these topics are like prescriptive in nature to say that do this and things are going to be fine. But the advantage of following up on any of these topics is, I think that's just a very simple intent to deliver the customer experience, because today the users' needs, the user expectations are fast changing, and therefore we need to keep pace with the technology and the need to make our organization agile and faster to address the needs. So I don't think so the user today can wait weeks, months for any feature update, and to get that experience delivered appropriately and to their delight, I think we need to embrace many of the topics mentioned here.
Let's
Yeah.
not set agile equal to we introduce safe. Please not, right? Maybe we should skip the word agile in general.
Oh yeah, sure. So that takes us to the last macro theme, and I already know that we have a question that is there in our backlog to be answered. But before we get to that question or any other questions, before we come to a close of this webinar, two topics, one in adoption and definitely the topic that is trending in Europe, at least the EU Data Act. So let's start with Sophie, Daniel first, and then over to you, Michael.
So the short explanation for Sophie really is we want to, we as the AWS has been a founding member, and ARM, for example, has been a founding member. We want to create an ecosystem or framework where that helps our customers to be able to create apps on the cloud as well, that are able to run on the cloud, abstracting the hardware, abstracting peripherals maybe, as well as on the car, as well as on different car models or brands and so on. That is the goal for Sophie, actually.
Maybe also the right time to pick up the other question, which is about the industry initiatives. Of course, we have Povisa, Digital Auto, Sophie, Eclipse. What is our view of adoption among OEMs? I think that's the question.
I think it's good that they exist, and I think it's good that it has momentum. I mean, clearly with GM pulling a bit out of SDV and the U protocol, that that was a bummer. It's a good ground to grow things. It's a good ground, right, to open source software and get feedback and discuss things. But we can't have the expectation that any of those will solve this entirely. I mean, if you think about de facto standards in software development or in the cloud and web world, like Docker, Terraform, they do exist, those de facto standards, because somebody wrote really good software and open sourced it. And I guess these places can be the room for such a thing, but it still needs a driver, and it still won't be the one shot, let's build an SDV OS. I just don't see it happen. So I think these things are very valuable, but they're only one ingredient to what needs to be done.
Sure. Thank you. So let's move on to the last topic, 2-3 minutes or 4 minutes left, but last but not the least, the EU Data Act. Michael, over to you.
Oh yeah, I'm not a legal person, right? But for those, and I just sense that people might more technically focus in this call. But let's face the facts. September 2025, it needs to be in place. It's not optional. And I mean, for those who have not heard about it at all, EU Data Act basically says users or data from connected devices and machines, users need to be able to access it, users need to be able to use it, and they need to be able to basically choose different processing services. Meaning that OEMs, in that case, the data that gets produced in vehicles need to be accessible for others in a reasonable way. And there are like very legal terms in what way. And well, as I said, it's not optional. So people will have to fulfill this. But I also see this as, take this as an opportunity. Because from a legal point of view, you need only to be, provide raw data. Why not offer, good, aggregated, pre-cleaned data and take some money for it? Or at the same time, if you build to have, the interface anyway, you can use the same interfaces then also for your internal apps. So I think more people see it as they're obliged to comply. Well, yes, they are. But I think sometimes people don't see this as an opportunity and also a chance just to clean things up. Because if you handle your data that way, I guess you're probably good.
So I think we are into the last minutes of this webinar. So I would also like to thank Daniel and Michael for their time. But even before we close the webinar, some closing remarks from you, Daniel, closing remarks from you, Michael, and then we'll end to the closure.
Yeah, thank you. So I think we did a really good start, actually, with the SDV Pulse report. And I already sense, get feedback from our customers about very positive feedback on that from our customers about that. And I'm hoping to, I'm looking forward to our next release, actually. So thank you for that, for driving that, Sriram. And yeah, that should be my closing remarks.
Thank you.
For me, it's both. On the one hand, things I'm very slow getting to mass adoption because producing a new platform or new EE architecture just takes this amount of time. Some are faster than others, but at the same time, since we wrote it, I already have like 4 or 5 things I would say, I wish they would be on there. And maybe thanks for everybody for joining. I hope you found this interesting. But also let us know what were we missing from your perspective? What should be on that? It's not, because as we said in the introduction, highly opinionated what we wrote down there. It's still interesting, hopefully.
Absolutely, and that's also my closing remarks. So this is what you might ask, why 40? We probably started collecting topics that each one of us had. Maybe the list was about 80, and then we wanted to curate it, and that's where we got down it to 40. So when we do the next edition, obviously we would like to have your feedback, have your remarks. Maybe certain things are not at the right, intersections of the dimensions. So feel free to give us feedback. We are highly accessible over LinkedIn. Send us an email, give us feedback on the report itself. We would love to know more so that we are able to make this a better version and share and create it as a learning opportunity and an experience for each one of us. So on that note, I think we're also on time. Thank you all for joining in. Have a very good rest of the day and enjoy.
Thank
Thank
you,
you.
everyone. Bye.
Bye bye. Thanks.
Bye.